Acids, bases and salts. Acids are the chemical compounds that are sour in taste. Acids are present in many things that we use in our daily life. Curd has lactic acid, lemon has citric acid, and vinegar has acetic acid in it. Bases are the chemical compounds that are bitter to taste and soapy to touch. Bases are present in detergents, toothpaste, and hair dyes. Then how do we test the presence of acid and bases? We can test the presence of acid or base using acid-base indicators. Litmus is the most popular acid-base indicator. It is a natural acid-base indicator obtained from a kind of lichens. Blue litmus paper turns to red when dipped in acid. Red litmus paper turns to blue when dipped in a base. Red cabbage, turmeric, and hibiscus are some examples of natural indicators. Methyl orange and phenolphthalein. These are synthetic acid-base indicators. When methyl orange is added to an acid, it turns to red color. If it is added to a base, its color changes to yellow. When phenolphthalein added to an acid, there is no color change observed. But if it is added to a base, its color changes to pink. Here we have some chemical compounds. Let us test these compounds with acid-base indicators. Among these compounds, HCl, H2SO4, HNO3 and CH3COOH, they turns the blue litmus to red. When methyl orange added, they produce red color and remains colorless with phenolphthalein. This indicates that all these compounds are acids. The remaining compounds like sodium hydroxide, calcium hydroxide, potassium hydroxide, magnesium hydroxide and ammonium hydroxide, they turns the red litmus to blue and produces an yellow color with methyl orange. They form pink color when phenolphthalein is added. This proves that they are all bases. Certain acid-base indicators works with smell. These kind of acid-base indicators are called olfactory indicators. Examples: onion, vanilla essence and clove oil. Using onions as acid-base indicators. First, let us take a polythene cover and place some chopped onions in it. Place a small piece of cloth in the same cover along with onions. Now tie the cover using a thread or tape. Place this packet in the refrigerator for the whole night. On the next morning, take out the cloth from the cover. Cut 2 strips from the cloth as shown. Now smell these 2 strips of cloth. You will get onion smell from both the strips. Now place these strips on a flat surface and add dilute HCl drops to strip 1 and sodium hydroxide drops to strip 2. Rinse these 2 strips in distilled water separately. If you know why we need to rinse them in distilled water at this step, please write it in the comment section. Now once again, smell the 2 strips. The strip to which HCl is added gives the same onion smell, but the strip to which sodium hydroxide is added do not give any onion smell. It has lost its onion smell. Do you know why? The onion treated cloth strips become acidic since the vapors from the onions are acidic. When this acidic cloth strip is treated with HCl, there is no reaction between HCl and onion cloth. Whereas in the other strip that is treated with sodium hydroxide, there is an acid-base reaction between the sodium hydroxide and onion treated cloth strip. Here the neutralization reaction takes place. So the cloth strip loses its odor. Reaction of acids and bases with metals. First let us see the reaction between an acid and a metal. Add few zinc granules to a 5 ml dilute H2SO4. They both react and forms a salt called as zinc sulfate and hydrogen gas. So acid plus metal gives rise to salt plus hydrogen gas. Now let us see the reaction between a base and a metal. Add few zinc granules to 5 ml of concentrated sodium hydroxide and warm the contents using a burner. They both react and forms a salt called sodium zincate and hydrogen gas. So base plus metal gives rise to salt plus hydrogen gas. But all metals may not react with the bases in the same way. Reaction of metal carbonates with acids. Take 0.5 grams of metal carbonate like sodium carbonate and add 2 ml of dilute HCl. It forms a salt that is sodium chloride, water and gas. This gas, when passed through calcium hydroxide solution, it forms a white precipitate, that is calcium carbonate. We know that when calcium hydroxide reacts with carbon dioxide, it turns into calcium carbonate. That means here the gas produced in this reaction is carbon dioxide. So when a metal carbonate reacts with an acid, it gives rise to salt plus water plus carbon dioxide. Reaction of metal hydrogen carbonates with acids. Take 0.5 grams of metal hydrogen carbonate like sodium hydrogen carbonate and add 2 ml of dilute HCl. It forms a salt, that is sodium chloride, and water and a gas. The gas produced in this reaction is also carbon dioxide. So, when a metal hydrogen carbonate reacts with an acid, it gives rise to salt, water plus carbon dioxide. So, all metal carbonates and metal hydrogen carbonates react with acids and produce salt, carbon dioxide and water. Reaction between acids and bases. Take 2 ml of dilute sodium hydroxide and add 2 drops of phenolphthalein to it. Since sodium hydroxide is a base, phenolphthalein turns into pink color. Now add few drops of HCl. The solution becomes acidic and the pink color disappears. Now again add a few drops of sodium hydroxide, the pink color reappears. In this experiment, we have seen that by adding an acid to the base, we can reduce or completely remove the basic nature of the substance. In the same way, by adding base to an acid, we can reduce or completely remove the acidic nature of the substance. These type of reactions are called neutralization reactions. So when a base is added to an acid, it gives rise to a salt and water. Reaction of metal oxides with acids. Take a small amount of copper oxide in a beaker and add dilute HCl slowly by stirring. The color of the solution slowly changes to bluish green color. Copper oxide reacts with HCl and forms copper chloride and water. So, when a metal oxide reacts with acid, it forms salt plus water. Reaction of non-metal oxides with base. Calcium hydroxide is a base. When it is treated with a non-metallic oxide like carbon dioxide, it forms a white precipitate called calcium carbonate, a salt. So when a base is treated with a non-metallic oxide, it produces salt plus water. The common thing in both acids and bases. Take some dilute HCl in a beaker and fix 2 electrodes. Now take 2 wires. Now connect one bulb as shown in the picture. Now connect the free ends of the wires to a power source. The current flows through the solution and the bulb glows. Replace the contents in the beaker with glucose solution. The bulb does not glow. Replace the content of the beaker with alcohol. The bulb does not glow. Now again, replace with sodium hydroxide. The bulb glows. This shows that the bulb glows only in case of acids and bases. That means that acids and bases, they conduct electricity. Do you know why? Acids and bases, when dissolved in water, they produce cations, that means positive ions, and anions, that are negative ions. When HCl is dissolved in water, it produces cations as H plus ions and anions as Cl minus ions. These hydrogen ions cannot exist alone. They exist in the form of hydronium ions. In the same way, if we dissolve sodium hydroxide in water, it forms Na plus cations and OH minus anions. So, the common thing among acids and bases is that they both produce ions in water and conducts electricity. Dilution. If we mix an acid or base with water, it results in the decrease in the concentration of ions per unit volume. This process is called dilution. Dilution is a highly exothermic reaction. That means when we add an acid or a base to water, large amounts of heat is released. So always add acid to water slowly by stirring. Never add water to acid. If water is added to acids, it splashes out and causes burns due to local heating. Strength of acids and bases. All acids do not have same strength. In the same way, all bases do not have the same strength. We can know the strength of an acid or a base using pH scale. It has values from 0 to 14. The substances with pH 7 are neutral. The substances with pH below 7 are acidic and above 7 are basic. The acids that are closer to 0 are strong acids and closer to 7 are weak acids. The bases that are closer to 14 are strong bases and that are closer to 7 are weak bases. Importance of pH in daily life. The pH of water in water bodies is very important for aquatic life. Acid rains make the water bodies acidic, which causes a great damage to the water plants and animals. Plants need a specific pH for their healthy growth. Farmers test the pH of the soil from time to time to add necessary chemicals to ensure the proper growth of plants. Importance of pH in our body. Our stomach produces hydrochloric acid that helps in the digestion of proteins. If more acid is produced in our stomach, it leads to a condition called acidity. To reduce stomach acidity, bases like magnesium hydroxide are used as antacids. The tooth enamel, which is made up of calcium hydroxyapatite, which is dissolved by the acid produced in the mouth. The bacteria in the mouth feeds on the sugars and produces acids which reduce the mouth pH below 5.5. This causes tooth decay. Acids and bases in self-defense. Living things use acid bases for their defense. Bee sting has an acid which causes pain and irritation. As a remedy, we can use a base like baking soda on it. Nettle leaf sting also has acid and causes rash and pain. Its acidic effect can be neutralized by rubbing with a dock plant. Now let us know about salts. What is the pH of salts? Are salts neutral, acidic or basic? Some salts are neutral, some are acidic, and some salts are basic in nature. Salts of strong acid and strong base are neutral with pH value of 7. Salts of strong acid and weak base are acidic with pH value less than 7. Salts of weak acid and strong base are basic in nature with pH value more than 7. Now let us learn about the important salt, that is sodium chloride. Since it is used in our day-to-day life, it is also called as common salt. But do you know that it is the main ingredient in making many useful chemical compounds? Sodium chloride is used to make caustic soda, baking soda, washing soda and bleaching powder. Sodium hydroxide, NaOH. Manufacture of sodium hydroxide. When electricity is passed through an aqueous solution of sodium chloride, it produces three products, that are sodium hydroxide, chlorine gas and hydrogen gas. This process is called as chloralkali process. In this setup, chlorine gas is produced at the anode side and the hydrogen gas is released at the cathode side. Sodium hydroxide is formed at the cathode. Uses of the products formed in chloralkali process. The chlorine gas produced in this reaction can be used for water treatment, swimming pools, manufacture of PVC, in making disinfectants, and in making of chlorofluorocarbons and pesticides. The hydrogen gas produced in this reaction can be used as a fuel and also in making of margarine and fertilizers. The sodium hydroxide produced in this reaction is used in degreasing metals. It is also used in making of soaps, detergents, paper and artificial fibers. Baking soda, NaHCO3. Manufacture of baking soda. When common salt is treated with water, carbon dioxide and ammonia, it gives ammonium chloride and baking soda. Uses of baking soda. It is used as a cooking ingredient. It is also used as an antacid to reduce the stomach acidity. It is also used in certain types of fire extinguishers. Do you know why baking soda is added to food items? When baking soda added foods are cooked, the sodium hydrogen carbonate becomes sodium carbonate plus water plus carbon dioxide. This carbon dioxide gas makes the food item spongy and fluffy. So, to make the food spongy and fluffy, baking soda is added. Washing soda, Na2CO3. Recrystallization of sodium carbonate gives washing soda. Uses of washing soda. It is used in the manufacture of glass, soap and paper industries. It is used in the manufacture of borax. It is also used as a cleaning agent. It helps in the permanent removal of water hardness. Bleaching powder, CaOCl2. Manufacture of bleaching powder. Calcium hydroxide is treated with chlorine gas produced during chloralkali process to prepare bleaching powder. Uses of bleaching powder. It is used in whitening of cloth, paper, jute and linen fibers in their manufacture. It is used in industries as an oxidizing agent. It is also used in disinfecting. The white powder that is sprinkled near public toilets and garbage bins is nothing but bleaching powder. Plaster of Paris, CaSO4 1/2H2O. Manufacture of plaster of Paris. On heating gypsum at 373 kelvins, it loses water molecules and become calcium sulfate hemihydrates. It is called as plaster of Paris. Do you know why it is called as plaster of Paris? In 18th century, extensive mining of gypsum was started in Paris for the large-scale production of plaster. Since then, it's being called as plaster of Paris. Uses of plaster of Paris. It is used by doctors as plaster to support the broken bones. It is also used to make toys and models. This is all about the acids, bases and salts. Thanks for watching. Please like the video. Please share this video with your friends. Please subscribe to Grade Booster channel. Press the bell icon to get all the latest updates. Check the description to find links of other useful videos.